Okay, so now on to the second way to define the dictionary. Um, like I said, a dictionary is a set of key value pairs. So the first way we saw, we opened up a curly brace and just started typing in keys and their corresponding values. Um, Another way we could do it is we could have some type of iterable object that contains um, two element iterable objects that correspond to key and value. So if you don't know what I mean, you'll see in a second. Let's create a tuple called key value. And that'll be a tuple. And the first element will be 5, 5. The second one will be toes, 10. The third one will be 107. So that's our key value tuple. Ooh, keep making that typo. Okay. And now let's convert this into a dictionary. So we'll call dict2 equals dict of key value. So as you can see, in this tuple, the first element of each two-element element, if you get what I'm saying, is the key. So 5, toes, 100 are all keys. We could do dict2 toes, and we'll get back 10 as expected. And then the second element are values. So this kind of goes to show that each of these three data structures in Python, and we'll revisit another one called a set in a second, each have their own functions associated with them. So we saw a list, we saw a tuple, we saw a dict. These three functions can take in another data structure that's iterable and structured in a proper format and convert it into whatever type it is. So we know that if we use the type function, we can see the type of the object. And let's try and convert key value into a list. So if we do key value, list of key value, we get a list of all of the elements in the key value tuple. So this is no longer a tuple. This is a list. Key value is still a tuple, but the output of the list function called on key value is a list. Okay, so we can also add elements to our dictionary using the update command. So dict2 has all these three elements. Let's say we want to add the element 9 to it. So we could do dict2.update, and we'll do 9:7. So that took in this new dictionary we defined on the fly and added all of its keys and values to dict2, which has now been mutated to contain a key for 9 and a value for 7. There we go. And the last key data structure in Python is the set. So we can define a set like that. And it's essentially the same thing as a set in math. It's almost like a list, except it doesn't take in any repetitions of elements. So just to show you what I mean, let's just define a list called rep, and for I 7, we're going to do rep dot 1. So here what I did is I used this range function to my advantage. We know that range of 7 contains 7 elements, and we're iterating through it, so it's going to do 7 loops. It's easier than doing a while loop and incrementing an outside variable over and over again. So this is what Python programmers call the Pythonic way of doing things. This is how you iterate a set number of times. So now if we show our rep list, we see that it has 7 ones. If we were to take a set of rep, sets are also defined with curly braces. It can get kind of confusing, that's why people typically just use the set function. It iterates through rep and makes it into a set. But rep only has one unique element, 1. So our set only has 1. Let's make set of rep into our own variable. And to add elements to a set, you would do rep set dot add instead of append 7. Let's also add -1. And let's see what happens if we try adding that again. Nothing, because -1 is already in our set. So those are 3 key data structures in Python. Very useful throughout any applications you might find yourself in. Now we're going to go on to functions in Python. So I'll first show you the very basic syntax of a function. You start it with def, then the name of the function, the argument, so we'll call that x, and this function will return x. It's an identity function essentially. So name of 7 will return 7, name of name. We'll print out that name string. We could do something like h equals name 8, and h has the value 8. So this name of 8 function starts by running. X is 8, it returns x. So this piece of code right here that I have highlighted evaluates to the number 8, and that gets assigned to h. Okay. We could also do something similar, like define name v for verbose, print x, return x. So now if we do h equals name v of 8, we're reassigning h to a different variable. The function prints out x, which in this case is 8, and then h also evaluates to x because the function returns x. I guess a very simple way to demonstrate taking in multiple arguments is, let's just define a function called add2. Functions must start with a letter. They can't start with a number, but they can contain a number in any other part of the name. So we'll call add2 a function of a comma b. So it takes in 2 arguments this time. And we'll return a plus b. So add2 7 will give us an error because we only put in 1, but if we also put in 3, we get 10. So that's a very simple function. It can be improved. Like as you see, it gave an error when we put in 7. So let's just say if we only put in 1 variable, we want it to just return that variable. So a simple way of doing this is def add2 a comma b equals 0. And then the same code as before. So if we do add2 of 7 again, we get 7. This right here is a default value for our argument b. So if we don't specify b when we're calling the function as we do here, it automatically sets b to 0, and then it just returns the number we put in. Now, this is great, but there is a problem. If you want to add multiple numbers, like let's say we want to add 3 numbers, we would have to do something like add 2 of, let's just say we want to do 5 plus 6 plus 7, so we'd have to do 5, comma, add 2 of 6, comma, 7, and it gives us our expected answer of 18, but this is annoying. And if you want to do more than 3 numbers, you'd have to continuously write out the number add 2, and it's just not fun. So the way that we can do that is we'll make a more general function called add, and we'll put in a weird argument here. It's called star args. So what this does is it allows us to take in infinitely many arguments from the user. So we'll start out simple. I'll tell you right now that what this does is it gives us a variable within this function add called args, and that's a tuple. So what do we know about tuples? We know that they are iterable. So we'll create a variable called sum, set it to 0, and then for I in args, sum equals sum plus I. And then we'll return sum. So what this does is it sets the number sum to 0, and then for every argument that the user plugs in, it'll add it to sum and then return that. So add 5, 6, 7 will give us 18 as we wanted. We could also be a little more sneaky, and there's a sum function in Python that works on tuples, so we could just do return sum of args. Add 5, 6, 7, and it gives us 18. So either of these two approaches work. This one obviously saves a bunch of lines of code and does the same thing, so there we go. We could do add 1, do add 1, 2, 3, 4. Let's just say we want to pass in some kind of an iterable object, like a range. So we could do add star range 10. And that gives us the sum of the numbers in the range of 10. So what this star does is it tells us that every item in the range 10 will be passed in as an argument. So we could even do 100, and this literally adds up 100 numbers. So that's how you take in a flexible number of arguments. Okay. Another really useful feature of Python is that functions are objects. Python can be used as a functional programming language or an object-oriented. We'll get to objects in a second, but it's very useful that we can do something like type of add, and it'll give us a function. So now let's just say we want to create a function that multiplies a number by a given value. So let's just say mul by 2 of x. Oops, sorry, forgot the def. And we'll just return x times 2. Okay, straightforward. This can get annoying if we want to make multiple. So let's just say I want to make one for 3, 4, 5, and 6. We would have to define functions like this over and over again, and it gets to be a lot of lines of code. So to save some time and space, we can do something like def make multiplier of, we'll call it m. So now what we can do is create a function within this function called, let's call it our multiplier. That takes in a variable called x, and that'll return m times x. And then this function will return our multiplier. So this function, makeMultiplier, returns a function that we can use. So let's just make a function called mul by 3, and just to show you that it's not previously defined, we get a name error because there's no such variable. Let's set that equal to makeMultiplier of 3. And now if we call mul by 3 of 3, we should get 9. There we go. So this is a principle called higher order functions. You can return functions, you can define a function within a function. It's a very useful feature of Python. I guess the last thing I should tell you about functions is just a very useful thing that programmers do when they're defining functions. We made this function called makeMultiplier, but sometimes people who are using your program and your functions may not know what that means. What does makeMultiplier do? What kind of arguments does it take in, etc., etc. So we can do something like def make multiplier m. And now before we write any code, we're going to start out with some triple quotes and write a little description. So takes in a number m and returns a function and returns m times x. So now someone reading your code doesn't have to read through all of the lines of your code. It gets particularly easy when you're trying to do a very long function. It makes it so that you can just read this top part called the doc string and not have to go through any of the code. So now our make multiplier works exactly the same as before, but it just has this useful description for anyone looking at our code later. So that's a useful thing to be aware of. Now we're going to go on to classes. So classes are a very useful way of defining your own objects in Python. If you're familiar with object-oriented programming, this will all look very familiar. Defining a class in Python is very easy. So the syntax is simply class, insert your name of your class. So let's just make one called animal for this example. Now to the one method that every class needs is something called an init method. So that method takes in arguments and allows you to instantiate a new class. It creates a constructor function essentially. So a method in Python is just simply defined by writing a function within the class definition. So we'll do def underscore underscore init underscore underscore self. So all methods that will be applied to a particular instance of your class, which the init method must, will have this self argument. Okay? So we'll do self, and for this animal class we won't take in any arguments. We'll just create self.noise none, and that's it. So let's just say we want to create a new animal. We just do animal. We can create a new animal and get its noise attribute. And it's none, so when you type in none, nothing gets printed because that's the Python's null value type. Okay, so now we have a class called animal with an instance called noise. let's make a subclass called, say, mammals. To inherit from animals, we'll do animal in parentheses. So it's inheriting from animals. We'll do def init self noise. This time we'll set self.noise equals noise. We'll also create a method called make noise, and that will simply print self.noise. Great. So let's just say we create a mammal. We need a noise parameter when we're creating one. So let's just make it woof, and we'll tell it to make noise. There we go, prints out woof. So as you can see here, this make noise method, first of all, it's called by taking an instance of the class and then doing dot and then calling the function. But you never have to type in an argument for the self parameter when you're doing it in this fashion. I'll show you what I mean by that again in a second. Let's create a third class. So we had this woof method. Let's create a class called dog, and that inherits from mammal. So we'll create an init method, and we're not going to take in a noise parameter. You'll see what I mean in a second, but we will take in a breed parameter. So first what we're going to do is called super. This super method will return the class that the dog class inherits from, its super class. And in this case that's mammal. So we'll do super.init woof. And then we'll do self.breed, use breed. We'll create a function called getBreed, and we'll return self.breed. So let's create an instance of this dog class called Jasper, and we'll make him Maltese. So Jasper is a dog object. Let's get his breed. We get Maltese. Now here's something interesting. Jasper.make noise. And it works. Even though you can clearly see in our dog class we don't define a make noise function, it works because it inherits all of the methods from its superclass. So now you might have known that, but you might be confused at the fact that we never explicitly set a noise parameter, or even took one in when we created the dog. It just automatically gets woof. That's where the super.init woof comes in. So what it does is it takes our dog object and it does everything that happens in this init method. So what that does is it takes this noise parameter and sets it to the noise attribute of our dog. So if we do jasper.noise, we get woof as a string. And now that's not just for Jasper. Let's just say we create, let's just, do another dog of, I don't know. I don't know how to spell chihuahua. And we do that noise. It's woof, because every dog object gets this woof as its noise, as an animal. So that's just some basic classes and inheritance. We could go even further if we wanted, create another one for small dog, etc., etc. But this is the basics of how to define a class in Python. Now we're going to get to something called magic methods, and they're just as exciting as they sound. What magic methods let you do is to define a method on these classes that does some special behavior in Python. So you'll see what I mean in a second, because we're going to do a pretty lengthy example on that. But let's just make a third class just so I can introduce you to the power of magic methods. Let's just make a class called small dog. And just to make things easier, we'll just do super, init, and we will make the breed automatically small, just for the ease of use. Okay. Now, as you saw here when we just typed in this dog object, we got this really unuseful string. It tells you the type and it tells you the location in memory, but that's not so useful for our cases. So we're going to create a method called repr, and we will return small dog. We'll also create one called string, or str, self, and for that we will return small dog, just to do two different things. So let's just create a variable called small. That'll be a small dog. Small, that prints out the repr method. We can also convert it to a string. This is how you convert anything to a string. You use the str argument, and it prints out, it gives you the string method of this class. So you can go as far as to do something like, if we were to use this on our example from before, if we print Jasper, the default is it just prints out the repr, but we specified a special string for a small dog, so we can do print small, and it will convert it to a string using this str method that I showed you up here, and print it. So repr gives you a string when you execute it into a command like this, and string is used for converting it to a string or printing it. So that's just some of the basics of magic methods. Now we're going to kind of get a little bit in depth with the stuff by doing this optional demo where we create a linked list object. So you'll see how we can create some simple data structures in Python and how to make them really useful.